Hey, everybody, welcome to Data Engineers Lunch number 22. Today's topic is, that picture is not supposed to be my picture, it's supposed to be Will's picture, but Will is a data scientist and an author. He's a big part of the data community DC. He is presenting on Prometheus today. I'm the organizer, always looking for co-organizers and volunteers to help. As a volunteer, you're part of something bigger than this group. Actually, you get to interact with people like Mike, who's here today, and Will at the Data Community DC organizational level. Data Community DC believes that diverse communities are better and stronger together. We continue to build an inclusive culture that encourages, supports, and celebrates diversity in race, gender, sexual orientation, religion, and all protected classes. It connects and brings us closer. Everyone is welcome to come to speak and to volunteer as an inclusive community. That's our diversity statement, and we try to live by it as much as we can. If you know anybody, or if you are in an underrepresented community in the tech industry, we'd love for you to present, or whoever you know. We're part of Data Community DC. Data Community DC is made up of several groups, centered mostly around data. What do we cover at this group? Data Wranglers. We covered the get your shit together problem. How do you get data together? How do you clean it? How do you prepare it so that people can use it? And Data Engineers Lunch is about kind of the middle of that journey. Anyone new to this group that would like to just say hi and tell us a little bit about yourself?
Hi, I'm new to this group. My name is Bernard. I work as a data analyst in DC at a quasi-governmental organization known as USAC. And I'm really interested to continue learning about data, all things engineering, data science. I'm looking to actually transition to data science within a year. So I'm really excited to be part of this group and learn all there is to know.
Great. Well, glad you're here. Yeah, and if you have something interesting to talk about, we'd love to have you share it on here. Something fun, if you can talk about it. You said quasi-government, so sometimes government stuff we can't really talk about. So. Excellent. Anyone else that wants to say hi?
Hi, my name is Odysseus. This is my first time here joining this group. I work in health information technology, and we're planning to use Prometheus. So that's why I was very interested to attend this talk. So thank you so much for hosting it.
Great. Awesome. Welcome. Anyone else? Okay, well, we'll go ahead and, all right, Andre, did you want to say hi? I just saw you turn on the video. I think you have to unmute yourself. Oh, there we go. Looks like you're unmuted now. If you're speaking, you may be double muted. Sometimes the microphone has a mute button as well, and sorry, we can't hear you, Andre. Sorry about that. We're gonna continue forward. We can have a little bit of networking afterward as well. Go back to the presentation. Group rules: if you have a question, ask it. Be polite and courteous to others, and it's an opportunity for you to share, not just ask a question. And then obviously, Will, our presenter, can give you further guidance on what he prefers, but generally it's a community with conversation. Our company, Anant, is one of the sponsors. We help professionals build global data platforms. We specialize on Cassandra, Spark, Kafka, basically fast data, big data. DataStax is a sponsor and a partner. So is GW University. It's been an amazing sponsor for our group and also to the larger Data Community DC by providing venues when we have in-person meetings. Data Wranglers DC is actually both here in DC, as well as we've done a few events in Chicago. Now it's all virtual. So we have a couple of local sponsors. And then we have our organizational sponsors who help the larger data community organization. Anyone have any events coming up? Any job announcements? Anybody looking for work that wants to just step up? Nope. We have this data engineering lunch every, well, this is now, but we have data engineering lunch every Monday at noon. And then we have another Cassandra lunch on Wednesdays at noon. You can go to Data Community DC to find out more events. Oh, Will has a data visualization meetup. Let me put this up on the screen.
Yep.
Yeah, Will, you want to talk about that?
Yeah, so I also help run the Data Visualization DC meetup group. It's a fun group of people who enjoy looking at data, emphasis on the looking part. And we've got our monthly meetup coming up on May 13th. That is every second Thursday for the rest of the year. So it's a fun group.
Awesome. And Mike just mentioned that Data Community DC.
Yeah, there's a jobs board. Yeah.
Cool. This is this the same thing as the Dateable thing, or is this different than that?
This was a part of that. If you scroll back up actually to the browse current jobs, yeah, we've got a jobs board on the Data Community DC website, and so if you're interested in sharing a job, we can get that up there. If you're looking for a job, we still have some postings there.
Very cool. Awesome. Excellent. We will mention this going forward. Thank you. And back to the presentation. Yeah, that's it. Without further ado, I'm going to pass it to Will, our presenter. It's all yours.
Sounds good. Thank you. All right, let me go ahead and see if I can share my screen. Can we all see these slides now?
Yep.
Yes.
Awesome. So feel free to put questions in the chat as we go. I'll have a couple of good breakpoints for questions as well. But if you have anything burning, feel free to jump in. So today we're going to be talking about monitoring with Prometheus. So we've got a presentation and a couple of demos. And for the presentation, I'll be talking about monitoring in general, as well as a little bit about Prometheus. And then for the demos, we'll have Prometheus, Grafana, which is a basically data visualization layer that goes on top of Prometheus, and then a couple of additional demos, time permitting. So why are we talking about this today? Why should we care about monitoring? So we want to observe our software applications. If we have something running, it's helpful to know what it's doing or if it's still running, because we want to sleep at night. If you don't know if a data job that's running overnight is going to work or not, that makes it hard to sleep well, at least in my experience. So being able to have insights into how our systems are working or not working gives us confidence in reliability. And at the end of the day, if our data is not getting in the right place at the right time, we'll have both technical issues and business issues where if people don't trust the data to get there in a timely and accurate manner, they won't trust the data at all. So the flip side of monitoring is that if you're monitoring and watching something, you can send alerts. So you can get a text at 2 a.m. if you need to that says, airflow exploded, which better that things not explode. But if they do break, it's helpful to be monitoring so that you know what happens. So we also can monitor applications to improve their performance. If you have some software that's usually works well but doesn't always, having instrumentation and monitoring allows you to get a better sense of where it's working and where it's not, so that you can actually do performance optimization in a smarter and more data-driven way. So you can also, if you have a user-facing application, not quite so applicable for data engineering, but if you also have software applications that are very much user-facing, or even internally, we got a dashboard, something like that, being able to monitor how that application is responding to user requests allows you to allows you to quantify how users are experiencing it. So if some users have very high latency, that means that the application, the front end aspect, will feel slow, sluggish, unresponsive, could be timing out. Without monitoring, unless they start complaining, you won't know about that. So monitoring allows you to get ahead of some of those complaints. So monitoring. What is monitoring? Sounds like a simple question, and to a certain extent it is, but monitoring is how we observe our software systems. We typically observe metrics about a system, which are specific ways of counting things, looking at the rates of things, and looking at statistics about those things. So for counts, you can have the number of requests served for like an HTTP, a web server. You could look at the number of data jobs being moved around. If it's Airflow, the number of DAGs executed. And then you can use those to look at rates, which can either be counts over time or things like percentage utilization. How much of your Spark, how much of your distributed computing cluster is getting used on a per machine basis would be a great question for a monitoring platform. And then statistics is just sort of looking at those and slicing and dicing and looking at the comparative distribution, which comes up a lot in the form of percentiles. So if you're trying to optimize your system, you want to know, what's the average latency of a request, but you also want to know what's the 99th percentile, 95th percentile, et cetera. So you can say, okay, we've got our average performance, but what about the outliers who things take a really long time for? So another interesting thing to keep in mind is that if you have logging going on, you can aggregate logs into metrics. So in this example, for successful HTTP requests, you can aggregate that log into the metric of 4 successful requests. And then if you further aggregate that by time, you can store that in terms of requests per minute, all of that. So the important thing to keep in mind, if you have software that generates logs, you can turn those logs into metrics. So the monitoring ecosystem is big, and it's getting even bigger. Like, for example, Datadog, New Relic, Sentry. Datadog especially is I think 300-pound gorilla in this space, and they had an IPO 2 years ago and are worth, I think, $35 billion now. They're a huge company, and this is an exploding space in part because of the continuing move to the cloud and a move towards microservices, where if you have a lot of different computers doing a lot of different running a lot of different services, monitoring those becomes a huge challenge. And so having a platform where you can just plug everything in and observe it makes life a lot easier. So there are a lot of options in this space. I think Prometheus is one of the better ones, in large part because it's open source. So let's jump into that. So Prometheus, it's a monitoring and alerting platform, which it pulls metrics data from your targets. So you have target services. For example, Airflow is a software service that you can instrument, and then Prometheus can pull performance metrics from Airflow. You can also visualize and query those metrics with the web interface, or export it to other tools. There's a comprehensive API that a lot of things integrating to. The second thing we'll be looking at is Grafana, which is pretty much the go-to visualization layer to use on top of Prometheus. You can also use the alert manager to send alerts, based on rules that you can define and set up. So you can say if some metric, if the success rate drops below 99%, send an email, send a pager alert, etc. And then for more ad hoc jobs, where it's not so much a software service, but a specific batch job, there's a push gateway that you can send metrics to Prometheus. And today we're going to be mostly focused on the server and the web interface / visualization layer, but the alert manager and push gateway are also very good stuff. So, system architecture. If you think that there's a lot going on here, you'd be right, because it is a relatively large piece of software. That said, it is segmented. It is basically modular. So if you're not using the push gateway or the alert manager, that doesn't add too much. But basically, you've got the server, which pulls metrics from the target, the software, and then visualizes that in the web UI or sends alerts. And then if you have the push gateway enabled, it will actively receive any push metrics that you're sending to it, and so on. The thing that I want to comment on here is the time series database that makes Prometheus work. So Prometheus stores every metric as a time series, which means it's a set of values and timestamps. So at a particular timestamp, you'll have the number of CPU or the number of requests received and served, etc. And that allows you to do very good both visualizations and alerts, because everything is time-based. And that said, one of the problems that you get into is that there are so many different time series and ways that you can start slicing this data that some people will refer to this as the cardinality explosion, where you say you have HTTP requests, you have some web server that's receiving requests and answering them. What if that web server is actually a cluster of microservices just deployed across a dozen data centers around the world? Suddenly, if you're thinking about the specific, the performance of that system, you probably won't ever have the entire system fail. You'll have individual nodes or machines or services that start having issues, and so you'll need to be able to slice that and get down into the weeds. And Prometheus makes that much easier than it would be if you're trying to figure out what's going on yourself. So let's talk about the Prometheus targets, which is just the nomenclature for referring to an instrumented software application. And there, once you've you've added the instrumentation code to a software service, then Prometheus can identify that and pull the metrics that it's exposing. And there, the instrumented services, they just expose that data as a web API that Prometheus can find. An important thing to note is the Prometheus ecosystem is very robust. And so for most popular applications, there are basically plug and play instrumentation libraries. So you can just take the open source library, put it in your code, and it'll start exposing metrics to Prometheus. So it's very, very, very fast to get started. So if there are any questions now, actually, let me check the chat, wherever that went. More chat. Cool. So if there are any questions, feel free to unmute and ask them. But if not, I'm going to move on to the demo.
I just wanted to echo that, Prometheus is, it's not only huge in the sense that like everybody's already talking with it, it's kind of one of the main components of the cloud native movement, which is everything on containers. And without Prometheus and Grafana, I don't know what people would be using.
Yeah.
Yeah.
Again, Datadog and Sentry, New Relic, they're all fairly competitive with Prometheus. There are sort of pros and cons to all of them, but Prometheus is open source, which means free, so that's always good.
Yeah, good clarification. That's what I meant. In terms of like open source, there's nothing else out there. Yeah.
So can everyone see my desktop here and see Prometheus?
Yeah. Let
me make this a little bit bigger. So this is the Prometheus web UI, and it's fairly minimalist, and most of the actual configuration has to happen in a configuration YAML file. So the actual configuration, for the most part, you can't edit through the web UI, which I think is actually a good thing. But yeah, it's got alerting, it's got some visualization capabilities. You can look at the targets that are currently running. So let's look at targets first. So there are two targets here. One is Prometheus itself. Prometheus takes a straightforward approach to the question of who's watching the Watchmen and monitors itself by default. So you can see that we're monitoring Prometheus, and it's collecting that data from itself. I also have a local web server running on a Raspberry Pi that is also exposing metrics to Prometheus. And there it is, a fast API Python web server that is doing some local IoT data work. And I'll actually elaborate a little bit on that before we move to the Grafana demo, so that I can show you some real world data. And you can actually see, let's visit the Prometheus metrics. So Prometheus is running locally here, and it is exposing all of these metrics actively. And so the server is showing basically extremely detailed things about what's going on, how queries have been run, HTTP requests, etc. So a tremendous amount of information, and basically every web server or software application can be producing this much data in real time. So you start running into issues with a huge amount of large and generally useless data. In most cases, you don't want to be looking at this because that means that something's not going as well as you want. So this is sort of what the raw metrics look like, or the raw data looks like. Prometheus scrapes that usually every 5 to 15 seconds, and then puts that into its time series database, and then we can query it. So I'm going to go back to the graph interface, and here we can do a query and look at different metrics. For example, say we want to look at the HTTP requests, total. I'm going to execute this and make it a little bit bigger. Here we can see all of the HTTP requests for in this case, this particular metric name, HTTP requests total, is for the AngelNet server. And we can see all of the different types of HTTP requests by status, by method, by IP, and by looking at the actual URL path for those HTTP requests. And we can see that in the overwhelming majority, there are almost 3 million, so 2,865,000 successful post requests for the input method. And there, I'll talk about that a little bit more in a minute, but I've got IoT sensors that are posting data to the server. And so that's what we'd expect to see. Now you'll note, these are static numbers. So if we switch to a graph, over the last hour, we can see it's a static number. Like the total, like it's slowly increasing, but it's not super exciting. So let's look at let's change this and you can use all sorts of functions in the Prometheus query language. And we want to look at the rate of those HTTP requests. Requests total for the last, I think, 5 minutes. We specify the metric, the function, and the time, and we execute it, and we can see. So these are the rates per 5 minutes over the last hour, and so we can see that it's consistently been doing about 0.3 requests, or a third of, one request per 3 seconds for the successful post requests. So this visualization, like it's functional, very functional. It's built in, very useful. I'm going to move on to Grafana at this point, but first I want to switch topics real quick and talk about service discovery. Prometheus has great support for service discovery, which basically means if you're dealing with Kubernetes or some other like clusters and containers and microservices, you'll start running into the issue of having a lot of different services that come and go. And so it becomes non-feasible, or it becomes infeasible and challenging to manually set up all of the metrics and IP addresses and the destinations, because you'd have to configure every service before it launches. So you can use service discovery to make those automatically discoverable by Prometheus. And so then it can go around and collect metrics from, say, every service in a cluster, as opposed to only the services that you've specified. So this starts getting really useful if you're operating at scale across a lot of different services. I suspect Rahul can probably speak more about how service discovery is incredibly useful.
Yeah, when we're working in the cloud native world, each pod has potentially different containers that are coming up, and there's generally in a Kubernetes cluster, you'll have several pods representing several applications, and so a pod is a collection of containers and volumes, and you can just imagine like a decently sized application will potentially have like 10 pods made up of maybe 30 different types of containers, things that come up and go away, like jobs or like the sidecars. I mean, it just grows exponentially, and having to configure that manually would be like a full-time job. Yep. It would be impossible.
Yep. Yeah. So service discovery is effectively automating that configuration process, and it's great. So moving on to Grafana. If people have questions, feel free to put them in the chat and or ask them out loud. But I think Grafana as a data visualization layer will make Prometheus look more useful. So welcome to Grafana. Grafana is a data visualization platform that allows you to make basically dashboards and consoles. So I've got one that I already made. I'm going to go over to it. And this is looking at it's pulling this data from Prometheus and is looking at the HTTP requests, a couple of specific visualizations over the last hour, and it's refreshing every 5 seconds. So each data point here, it represents a reading per 5 seconds. And you can see that the success rate is 100%. Nice. We're not having any bad requests. The number of requests is pretty stable, which, given that the number of devices on the network and their code isn't changing, I'd expect that to be pretty stable. One thing that's interesting is the request duration. Here we've got this in percentiles, and we've got from bottom to top the basically slowest through, or the fastest through slowest percentiles of HTTP request duration. So this is how long the server takes to respond to an HTTP request. So for example, let's see, 21. So about 10 minutes ago, 5% of, fifth percentile, 5% of requests were answered within 121 milliseconds, and 5% were answered in more than half a millisecond. So more than half, or yeah. So overall, quite fast. And now one thing to note here is that Prometheus optimizes for reliability. So there, Prometheus wants all the data to arrive, and it wants it to arrive quickly. Accuracy is a secondary concern. It tries to be accurate, but there are a lot of approximations and various ways in which you won't always get all the data 100% of the time. So Prometheus is not the place. Like, don't replace your source of truth, like transactions, with Prometheus. It's not the tool for it. But if you want to get a comparative idea of how your services are performing, this is a great way to do it. So we had a question in chat. Does Prometheus require any agent to be installed on each monitored server? So you do need to instrument the server or the server application with the Prometheus code. That said, in many cases, if you're using a framework off the shelf or a well-known framework, there will be a Prometheus instrumentation tool for it that provides almost all of these types of metrics by default. And so it can be very little work. For example, for Fast API, for using the Fast API web server framework in Python, it's 2 lines of code to add Prometheus monitoring to a Fast API application. For Flask and Django, it's like 5 or 6 lines, but it's very, very easy in most cases. And it's also not hard to define custom metrics and send those to Prometheus. So you do have to modify your services a little bit, but it's a very, very low lift. There does need to be, like, you do start getting into issues you start getting into issues with user-facing applications, because by default, the Prometheus instrumentation is available as an API to anyone with access to the application, which means that you'll be exposing all of if you have it totally public facing, all of these metrics, this metric page will be exposed to anyone with IP access, with access to that service. So you may want to go about and add some additional firewalling, additional rules around making sure that the metrics page is only available to Prometheus, or put it in the same way that you might want to restrict access to the admin console if you have a web application that has an admin console. So Grafana makes it very easy to take all those metrics that Prometheus has and turn it into useful, interesting, and beautiful dashboards. For example, let me actually go into here and show you this. And you can basically take the Prometheus query language code and just turn that into a chart, into a time series. So you've got it's looking at the histogram quantiles. Yeah, so 0.5, fifth percentile, and looking at the sum and the rate. And we're also filtering it by input here, because we only want to look at the actual successful data pushes here. So let me go ahead and go back and show you what this would look like, because this 100% chart, that's what we want to see, right? All green, all exciting. How about I show you what that looks like when we're getting some bad data and bad requests. So let me show you what all this data, what the server is actually doing. So this is a recording of a PowerBI dashboard that I made for the IoT network. So I've got these ESP8266 IoT devices that I made myself, and they're collecting temperature, and humidity, and light levels around my apartment. they're sending that via Wi-Fi to a Raspberry Pi in my nice little computing cluster. Very high tech, nice little data center there. The server is running there, and it's saving that data to a Postgres database, and also sending it to the Power BI real-time data gateway, which this dashboard was pulling from. And you can see it's got all sorts. It's showing the data and all that. Refreshes live every 5 seconds. So this is just a GIF recording of it. So this server, this Raspberry Pi running the web server, is what's exposing these metrics. So that little Raspberry Pi is successfully serving 100% of HTTP requests. I'm going to switch over to VS Code, and I've got a little Python script here. It's using requests and TQDM for a nice loop, and it's going to loop through a range of 100 requests and make. Actually, I want to change that back to 1,000 requests, and I want to make 1 in 5 requests have bad formatting, so they get rejected. So for the iterator modulo 5, if it's 1, it'll do an A, otherwise it'll be a 1. And if it is a letter like A, the server will reject it and return an HTTP 400 error. And here, let me make that a little smaller. We've got the full string here, because basically each sensor sends the data as an HTTP post request to the server, and it encodes the data as the URL parameters. And so here it's going to say that it's a test, and then every 5th request will have bad data. So let's go ahead and run this here. And you can see it's starting here. I'm going to actually move this to this side and bring VS Code back up. Oh, that broke. Oh, you can see it working. And the HTTP success chart over here is the number of the ratio of successful HTTP 200 requests over the total number of HTTP requests. So if every request is successful, it'll be 100%. If half of the requests are successful and half aren't, it'll be at 50%. And you can see that it's starting to drop over there. So we were down to 80% or 81% being successful, as we're hitting the server with the occasional bad request. We can also, I'm going to actually minimize this a little bit more. We can see the number of requests is also spiking. And interestingly enough, it's still a little early to say, but it appears that the time to service the requests is also decreasing, which is something that you see sometimes with services when and computers when they'll actually get faster in response to more traffic, weirdly enough. Though oftentimes things go the other way and get slower when they have more traffic, making everything get worse. So we're about 70% of the way through this particular error test. And we can see that previously we were at basically zero HTTP 400 requests. So all the requests were good. There weren't any error requests. And now we're at like 1.5 per second. Question from Joe: how many cores on the server? I believe that the Raspberry Pi, I think it is a 3B plus. I want to say it has 2 cores, but I will check that. Quad core. It actually has four cores. So the error generating code has now ended. So we should see everything start returning to normal. Yep, I'm going to see error rates are starting to drop. And within just a minute, they should be back to normal. I think to give a little bit more context to Joe about how powerful the server is. So I'd say this Raspberry Pi is about equivalent to I'd say probably the like smallest EC2 medium instance you can get your hands on. Like it's a decent amount of compute, but it's still pretty small. And I'm going to change this to the last, let's call it 15 minutes to get a better sense of how that looks. And we can see that now that the test is over, we're back up to 100% success rate. And the number of errors is back to 0. 0 errors or 0 bad HTTP requests per second. And interestingly enough, the request duration is still, it's still warmed up, still serving things even faster. One thing that I have not done that is on my to-do list for this particular IoT project is to add instrumentation to the Raspberry Pi itself. You can instrument systemd to expose Prometheus metrics. And so there we could have looked at like temperature and clock speed during this as well. Another question in the chat is the post data being stored in the time series database? Yeah, so all of these metrics here are being stored in the time series database. The actual data from the sensors is being stored in Postgres, which is also running on the Raspberry Pi. So that concludes the demos and presentation. Any questions or comments?
Yeah, just thank you. Appreciate the presentation, Will. And actually, the next week's presentation is a follow-up to Will's presentation. So Prometheus isn't just Prometheus anymore. Prometheus is like a protocol in that the PromQL could be backed by anything. And so there are actually, I think, 3 or 4, I'll compare them and contrast them, but there's 3 or 4 different Prometheus, I don't want to say variants because they kind of work with Prometheus, but there's some Promethei that are aggregating from other Prometheus servers. And then there are others, so that's kind of like a federated Prometheus. And then there are others that basically become a Prometheus at large scale, backed by different data storage mechanisms. So either block storage or like Cassandra, because you can imagine if you're Google, for example, the whole company runs on containers, and you want to monitor everything and you want to have Prometheus, then you've got to have like a massively scaled instance of Prometheus. And Prometheus itself is like a microservice. So, at some point, its job is just to collect data and store it pseudo temporarily, but you want to like have it for long-term storage, you got to use something else. So, because Prometheus is a protocol, people are doing cool experiments with it, and yeah, it's like a movement. I think Prometheus is more of a movement. And everything that you showed on Grafana, because it's PromQL, you could point it to like Cortex, or Thanos is another name for a different technology that's Prometheus compliant, and basically all of a sudden the same queries work. So yeah, quite a presentation. Thank you for coming out. Really amazing. Any other questions, folks?
Yeah, and I'll just add a comment on there about being excited about next week, because one of the challenges of Prometheus is if you're operating at that really big scale, you start running into effectively a metrics discovery process or problem, because each Prometheus server is by default entirely isolated, which is great for reliability. It means that if a Prometheus server is collecting too much data and falls over, it doesn't impact the rest of the service. And there are ways to scale it out, but you start having the issue where each Prometheus server, because of the limits of computing and the limits of your machine size, start being unable to collect all the metrics that you want to look at. And so you start having to know like, oh, which Prometheus server contains all the metrics for this cluster or this service. And at most, I think for most instances where we're talking about at scale, Prometheus can handle that with very, very little pain. But if you really start getting to, like hyperscale, global computing, you start getting into some real fun configuration issues there.
Yeah. And it's also not just that there's a lot of data coming in, right? There's the potential of other systems querying the Prometheus server. And so, so time series databases have a concept of like chunking in terms of how you chunk it together. And if you have a lot of different incoming data processes and you have a lot of outgoing data processes, like Prometheus isn't meant to be a transactional time series database. It's meant to be a monitoring system, right? So, and most, at least in my experience, most distributed platform management is basically like managing business, business intelligence about the whole cluster. And a lot of people are not interested in it. Like, what's happening with my application? What's happening with my application? So all of a sudden you have multiple tenants on the same core platform asking the same question. Hey, so you have Prometheus, let me see what's going on. And people are like hitting refresh, and it's like, okay, well, hold on a second. Let's figure out there's a better way to do this.
Yeah. Prometheus is not a replacement for a proper data streaming platform or a data warehouse.
Yes. Yeah. Exactly. And it's not Splunk either, right? It's not indexing as I understand about time series database. Like, they're not built to be large scale indexes and aggregators. Like, it takes time for it to do that query, and so that's where the other technology, Prometheus compliant technologies we're going to talk about, we'll see like how it does it at scale. Because the moment you go from one node to many, many nodes and have multiple machines storing that information, you have to manage these indexes of the time chunks, and you have to manage, well, what happens if one of these nodes goes down? So that's where we have like persistent storage separate from the actual, whatever, Cortex or Thanos server. It stores it somewhere else, like block storage, because the last thing you want is the thing that's watching your system to go down. And I think Grafana and Prometheus projects, or maybe it's Grafana, yeah. People from the Grafana and Prometheus projects actually work on these other technologies. And like, I think it's Grafana Labs, like their hosted version uses these other technologies that we're going to talk about next week. So I'm excited to follow on. Thank you so much. Amazing. Oh, Joe has a question. Yeah.
Yeah, quick question. I don't know if you guys went over this, but what time series database do you guys like recommend? I don't know, like the two that I've heard of are an extension of Postgres, which I think is called TimescaleDB, and the other one I've heard of is InfluxDB, and I've read a couple blogs comparing the performance. And then the other thing I'm really interested in is this Loki thing coming out of Grafana Labs, which I don't think is backed by Prometheus, but from what I understand, it's like a CloudWatch alternative. Is that fair? Is that crazy? Just throwing that out there. Thanks. Great presentation.
Will, you want to take that question?
So I don't often work with a lot of large time series. So my go-to for smaller time series is usually just regular Postgres. And usually the performance hit is enough that I don't have to worry too much about that. But I think if you're actually looking at really big time series data sets, then looking at a proper time series database is the move there. I don't have an opinion on which ones are best.
Awesome, thanks.
Yeah, I just add on to what Will mentioned. So I just kind of looked at Loki, and Loki seems to be kind of a competitor to something like Logstash or FileBeat, in the sense that it's log aggregation, not metrics aggregation. So, logs are different. Logs are not just numbers and time. Time, key, and value is what time series databases store. A log aggregation system actually does several other things, which is it has parsing engines and it has indexing potentially if you want to do some pre-processing. But at the end of the day, where does it go? I have to look into Loki, but it seems to me it's more like an aggregator. It's not necessarily a database in itself. So yeah, kind of like CloudWatch, but I think most people in the open source world would compare it to FileBeat or Logstash, or even FluentD is another one. Now, in terms of time series database, I've done a little bit of research on it. We actually had a talk on this either on data engineering lunch or Cassandra lunch, but there are tons of time series databases. The question is, what's your scale? So if your scale is like terabytes a day, then your InfluxDB may or may not like really cut it. You have to then look at some other time series databases that are then backed by another database. So there's several large scale databases in the, let's say the Cassandra world. Let's say there's one at Spotify called HeroicDB that is running on top of Cassandra, and it has an API, and you run it very similar to something like Prometheus. It's kind of in the background, but it's not really, it's meant for accuracy, right? It's not like Prometheus in that you could have a little bit of bad data here and there. But that's the second question I would have is like, what's your accuracy requirement? Because if it could be low resolution, then you can use Prometheus, or you could go use one of the variants we're going to talk about next week, like Thanos, Cortex. There's another one called M3, and then there's another one starts with a V, I forget. But these are like large scale implementations of Prometheus. But yeah, that's the question. Like you can always find a time series database. The question is like, how much information, you know? Yeah.
Awesome. Yeah, I'll look up low resolution and what that means, but that's awesome. Thanks.
Yeah. Yep. Any other
I
questions?
think, yeah, I'll add to that. The Rahul's exactly right to be thinking about what's the actual use case, how big is the data, how accurate does the reporting need to be. The thing I'll add there is how timely does it need to be, because if the data doesn't need to be that timely, and the actual consumption of that data, like depending on how you're actually aggregating it or using it at the end, you may not need to use it as a full time series, or you may be able to do some sort of hybrid system where you have much slower batch storage and then some streaming solution for real-time reporting. Because one of the issues that a lot of these tools run into is it's not too, there are a lot of challenges, but it's not too hard to get a huge amount of data from one place to another really fast. Persisting and storing that data while also having that speed starts becoming like a real challenge, especially when faced with the inevitable issues of networks and congestion and hardware failures. You start running into some near fundamental levels, fundamental limits of distributed computing.
Yeah, and actually,
awesome.
Yeah, I just looked up on Grafana's site, and they have something else called Metric Tank, and basically it's graphite that scales. And I'm kind of like looking up the information, but it seems like it's also backed by Cassandra. So look at Cassandra, because people just use that natively as a time series database as well. Cool. Awesome. Any other questions? Okay, I think Gotham had a question. How big does TSDB get in GB or TB do you normally see? Will, you want to answer that?
Ooh, so it depends on how much data you're pushing into it, or it's pulling into itself. But usually, it really depends on what scale you're working at. Rahul, do you have a better answer than that?
Well, like that's all capped by your machine, right? It's Prometheus will get as big as it can get in terms of the hardware that you're running it on. So you have 0.5 terabyte of memory, and you have, big enough disk space. I mean, it ultimately is capped by memory. I think all software is capped by memory, disk, and bandwidth. Bandwidth is never hit. nobody ever hits the bandwidth limit unless you're like streaming video, right? But it usually goes like this. It's like at the very top, bandwidth is the highest one to kind of achieve, like to hit a bandwidth limitation is like, that's when you're like $1 billion company, right? Where you're always, or whatever, you're totally like over, over the capacity. But the next thing is, the next kind of bottleneck is underneath it is like, how fast is your disk, or how big is your disk? And then below that is essentially your memory, and then finally your CPU, right? You can only go as big as your CPU. So it just depends on how big your computer is.
I think by default, Prometheus attempts to retain, I think, 31 days of compacted metrics, but it'll start compacting older metrics to reduce the level of detail, and then deleting older metrics as it runs out of time or memory.
Yeah, and I'm just kind of like looking at the specifics, right? Eventually, as I mentioned, it's going to come down to CPU, because it has its own internal garbage collection, and if you're gonna hit a particular limit, eventually every software has that same question, right? How much can it handle on one node? But Prometheus as a core application is not a distributed database. It's a time series database on one machine. And the other technologies we're going to talk about next week, those are the ones that you have no cap, because we're broken down the problem into many, many, many machines. Cool. All right, folks, we are at the almost at the top of the hour. Let's thank Will for an amazing presentation, great discussion. So thank you so much, Will, for coming out, and really glad you did this, because then it prompted me to kind of start getting started on the next week's presentation. So thank you, appreciate it.
Perfect. And the one closing comment that I have is that the Prometheus documentation is really, really good. It's well laid out, easy to read, technically detailed. So if you want to learn more, check out the documentation. And if you want to see an example of great documentation for an open source project, also check it out for prometheus.io.
Awesome. Thanks, Will. Everybody, you all have a wonderful rest of the day or evening, wherever you are in the world. And we'll see you same time, same place next week. Take care. Bye-bye.
Thank you.